Ladies and gentlemen, today we're going to look at another leetcode question and its solution. This time it's question number 41, first missing positive. By the way, this video is part of a much larger series on leetcode's questions and solution. Just in case if you are giving interviews, this would definitely help you. I'll provide a link to the playlist at the end of this video. And if you haven't subscribed to this channel, please do so. Just in case if you want to find this channel again for cool interview videos, you can do so. Please subscribe and welcome to Interview Nest. Alright, so let's start by looking at this question, shall we? First of all, you have to go to leetcode.com. If you want to look at this question, click on the problems, and then you'll find this number 41. I guess that might change later on, but yeah, just you have to find using this string, first missing positive. As per leetcode, it's a hard question. I think it's because if you want to do this problem using the complexity this asking for, then it becomes a hard problem. Otherwise, it's a mid-level question. Companies, pretty much all the big companies like Microsoft, Amazon, Google, Adobe, Uber, they're all asking this question, so it is an important question. And I found this question very interesting. You know, you need to spend a little time when you were asked this question. You need to spend a little bit of time to understand it. If you don't do that, you can get in trouble. But if you spend a little bit more time, you can get this question very easily. This is why it can get really hard. They want you to implement this in ON time complexity and constant space complexity, which means you're not supposed to use additional array. However, what we are going to we're going to look at three different complexity. First, we'll start with an easier one, and then we'll improve it to achieve this one. So we'll do three solutions. Okay, let's start with a question. Given an unsorted integer array, nums, find the smallest missing positive integer. So the key value here is unsorted integer arrays. We need to find the smallest missing positive integer, which means no zero, no negatives, only positive integers, and smallest. So let's look at an example. So they provided three sample test cases. The first one is if the numbers are 1, 2, and 0, the output is 3, which means 1 is the smallest positive integer, then 2, which already exists, right? So the next one is 3. So that's why the answer is 3. Let's look at the second one. 3, 4, minus 1, and 1. Obviously, we don't care about minuses. So we start from 1. 1 is there, but 2 is missing, right? So the answer is 2. And the last one is 7, 8, 9, 11, 12. Obviously, the smallest one is 1, so 1 is missing. All right, so it's time to do some analysis before we start writing our code. Because during an interview, if you get a problem, I would say pause for a few minutes, understand the question, find the solutions. You know, if you can't find the optimal solution right away, just use brute force solution and then improve the algorithm, right? Because you don't want to waste time. So we're going to do the same thing. What we are looking for first missing positive integer inside a given array. So let's look at this array. It's 1, 2, and 0. It's not sorted. So what is the smallest positive integer? That is 1, right? So I would say, is 1 inside this array? Yes, it's there. Okay. Then, do I have 2? Yes, I have 2. Okay. Do I have 3? No, I don't have 3, so the answer is 3. Same thing inside this array. Do I have 1? Yes, I have 1 here. Do I have 2? No, so the answer is 2. And for this one, it's pretty clear. Do I have 1? No, bingo. 1 is the answer. Instead of searching every element, 1 is, if I just first get rid of all the negative numbers or anything duplicate, that would give me a cleaner or smaller array. And also, I might want to also remove 0 because 0 is also useless, right? Then if I sort it, so let's say for this array, if I sort it, it would become 1, 2. And then if I remove 0, this would be the array, right? Then I have to simply check if the number at index 0, right? So if I say, let's say this is the array n. So number at index 0 has to be 1. If it's not there, then that's the answer. If it's there, then check index 1 and the answer should be 2, right? If it's not there, then whatever the next number is the answer. If you run through the entire array, can't find it, then the next number is the answer. And that's the easiest algorithm. All right, let's start coding. So we're gonna write our function called first missing positive, and it's gonna take some array, let's call it nums, and it will return that number, right? If I pass an array, it will return a number, so that's fine. And I'm gonna execute this function, so let's copy this and console log this, so I would know what is being returned. And I'm gonna pass right now some random numbers where there's some duplicates, some negatives. Okay. All right, so first thing we're gonna do is we're gonna remove all the negatives, and also we're gonna remove all the duplicate numbers. So for that, to remove the duplicate, it's pretty simple. I would say I can convert this array into set. So those who don't know much about sets, it's pretty cool data structure. In JavaScript, it basically holds unique values. So the way it works is if you declare a set and then pass an array, and this would remove all the duplicate values. And if I want to get the array back, then I would spread it, and this would give me an array without any duplicates. So let's get that out. And if I console log this one quickly to see if it really works, I would get all the values without any duplicate. So second thing I'm going to do is now I want to filter out any negative or zeros. So for that, it's pretty simple. I can use the good old filter function. So I can say nums equal to nums dot filter. If there is any value greater than 0, then keep it, else remove it. And I can also sort it. So I can chain this and sort it by return. So this function first sorts the array, first filters the array, remove all the 0 and all the negative numbers, and then it sorts it. So if I console log again, and if I run this, I'd only get 1, 2, 3, which makes sense. All right, so now all I have to do is check each number and see if it matches the index. I can use a for loop or while loop. If you have 1, 2, 3, right, then I want to check that this is the index here at 0. The index here is 1. So I want to check at index 0, do I have 1, right? So for that, I would create a variable. Let's call it let j 1. And I would say j is nums I. So it checks if num0 is equal to 1. If that is the case, then I want to look at the next value. So I'm just going to increase the value of j. That's if not the case, right? Else I want to return j. And if I go through the entire array and if I still can't find that number, then the next number is j anyway, right? Because that's the next biggest number. So I would say return j here. And this is lower j. So let's run this. There's a one, I need to do this nums because it's not supposed to be num, it's supposed to be nums. And I would get 4, which is correct. Now let's go through our test cases. So I'm gonna pass our first test case to see if it works. So this should give me 3. Let's try our second test case. It will give me 2. And the last one should give me 1. Okay, so it looks like it's working. Now let's improve the algorithm. First of all, what is the complexity of this algorithm? Let's understand it. If I filter something, I have to go through the array one time. Same thing here. If I remove something duplicate, I have to go through array one time. So this is O of n, this is O of n, but the sorting is usually the most complex. The best sorting is usually n log n. So the sorting, this would be n log n, and this is again going through one time. So the complexity of this algorithm is actually O of n log n, right? So we can do better. The requirement is we need to do it in a linear complexity. So how can we achieve that? Now we learned something from this exercise is that because the array is not sorted, it's hard to find things. And for that, if we use objects, by iterating through the array only one time, we would know all the numbers, and we can easily find that from the. So for that, I'm going to create an object, and then I'm going to write a for loop that would go through the entire array number by number. It will save each number here. So object would hold all the unique values. So let's do that, 0. And for every number, we're just going to push it into object nums I, and we're just going to set a value to like 1 or something, because that doesn't really matter. So in the end, if I just console log this object, and let's take some weird example, not this one. Let's say -2, 0, 23, -5, and then clear it and run this. I would get, it would automatically remove duplicates because now it's indexing them. And I can easily find, if I want to find 1 here, I can easily find in a constant time. So that's the advantage of using objects, because finding something is constant time compared to array where I have to, it's a linear time because I have to look through every single number. So now that we have all the number where we can find them in constant time, I'm going to write another loop. And this time, what I'm going to do is, I already know, instead of starting from 0, I'm going to start from 1. I'm going to go until less than equal to num's length. And then this way I can check if 1 is there. Remember our original algorithm, we check number by number. If the number is there, then we looked for the next number, and lookup now became constant, so this becomes easier. So all I have to do is now I would check if the object is, if the value I, which is starting from 1, is not inside this object, then we simply return I. So we don't do anything, right? So it goes from 1. Do I have 1 inside here? Yes, I have it. Do I have 2? Nope, I don't have 2. That means return 2. That's it. So, however, for space, we are also using an object which is occupying n number of values. So the space complexity is also O of n. So if I run this, I would have to, well, it is returning n anyway here. And if I can't find anything here, let's say outside here, then I would have to return the next value. So I would say return nums.length plus 1. The biggest missing positive that you can have is the length plus 1, right? Because if I get a sequential number 1, 2, 3, 4, 5, then the next missing number would be 6. Right? So it's a length plus 1. So this one is speed-wise, it's O of n, which we needed, but space-wise is also O of n, which is kind of redundant. We don't need this extra space. So let's look at another solution that would keep the speed O of n, but improve this by O of 1. So you can find this in a constant space. But we want to do it in a constant time without using an array. So we have to do it in place. So we have to swap within the arrays. Now, what are we swapping? So let's take a look at this example. Let's say if I have -2, 3, 1, and 5. So if I somehow can find place for each number, right, the right index, then I can put them in that right order using O of n complexity for time complexity. And then once that is done, then I can easily find which one is not in place, and that is our first missing positive. Okay, so let's look at how it works. So I'm just going to copy this here, and then this would be for reference, right? So let's start with -2. So -2 doesn't actually belong anywhere here inside here, right? Because the index would be -2. So we're not going to do anything. Anything that we find misplaced, we just keep it there for now. For 3, the right index to do is 1, 2, and 3. So it belongs here. So what I'm going to do, I'm going to swap 3 and 1. So let's do that. So I'm going to do 1, and this will become 3. Okay, but because I swapped, I need to go back to one number. So I'm going to reconsider the same number, 1. So where does 1 belong? 1 belongs the first location, right? So I'm just going to swap this and this. So I'm going to do 1 here, and minus 2. Again, because I swapped, I'm gonna look at this again. Where does minus 2 belongs? It doesn't belong anywhere, so it just stays there. What about 3? Again, it's at right place. What about 5? 5 doesn't belong here because it would actually go outside this array, outside the length of this array, right? So now I have all the numbers that supposed to be where it's supposed to be, and there are some misplaced numbers. So now all I have to do is check if 1 it is location, yes. Is 2 is its location? No, because I have to do sequentially, and so 2 is missing. And so that's a simple algorithm. Okay, so for that I would have to write obviously a for loop. Let I equal to less than nums dot. Now remember, first thing you need to do is where does this belong? So what is the index of this, right? So I'm gonna do, let's say, let's call this idx index equal to nums I minus 1. So for if the nums I is, let's say, 1, then I'm gonna put it in a 0th place, so it belongs here. So first, if something is at its right place, then, or if something that is duplicate, we don't touch it, we just keep things as it is, right? So I'm gonna say if I is equal to, let's say, index, or if number I equal to nums I equal to nums idx, which means either it's duplicate or number actually is in right place, then I don't do anything, don't move, right? Else if something is within the range, if something is outside the range, then also I don't do anything. If something that is within the range, idx is, let's say if it's greater than equal to 0, which is, it's a positive, but also within the range, right? So it has to be end idx is less than equal to nums dot length minus 1. So if this is within the range, then I have to swap those two numbers. For swapping is pretty simple. So I would do nums I and nums idx equal to, and I'm just going to swap it. Okay, and then I would have to I minus minus. Remember, every time you swap, you need to look at the swap number again, right? Let's look at what really produces this. So I'm just going to console log nums. For 1, 2, 1, let's say, what do we get? I think we get the same value. So I'm going to check 3, 2, 1. Let's see what do we get for here. I would get 1, 2, 3. So it actually sorts itself in a way, right? Without using log n and log n. So now we just simply write another for loop to check which one is misplaced. So I would say let I equal to 0. And if I want to check what's misplaced, then I would simply check if my I plus 1, remember 0th place should have 1, right? So if this is equal to nums I, or should I say not? So if this is not equal to, in that case, I would return I plus 1. After going through each number, let's say 1 is in the right place, 2 is in right place, 3 is in right place, but if it's still find nothing misplaced, then the next number, which would be 4. So I'll take the length of the array plus 1, and that would be the missing positive, right? Because the biggest missing positive is the length plus 1. It's supposed to be length. I always make spelling mistakes. So the time complexity is O of n, right? Because we went through one number each by iterating it. And the space complexity is constants because we are not using additional space. We are just doing in place. By the way, if you want to check out this example, I'll provide this example in the description. There will be like a CodePen link. I hope you learned something new from this video. And if you did, please like, subscribe, and provide a nice comment. And you can follow me. I have a Facebook group, Algo and DS in JavaScript. You can follow this group. And you can also subscribe my other channel, which is TechSet 2. This is actually Interview Nest is my secondary channel. And if you're looking for getting trained, let's say if you're giving an interview and you are confused and you need a formal training, you can contact me here on the Discord. You can also follow me on the Twitter, and I also have a Medium article that you can check it out. And lastly, if you want to buy my courses, I have Udemy course on React, and I also have a Udemy course on JavaScript, like a complete JavaScript solution.